Hello everyone. Welcome to IIT and GATE classes. This is lecture 4 on TOC. Okay. In the previous lecture, we were discussing construction of FA, and in that topic, I have already covered total 5 category of questions. Okay. That is still divisibility we have covered in the previous class. And in the previous class itself, I have covered one question on at least, at most, and exactly category. Okay. So let's continue the lecture. So in the previous lecture, as I have already told, we have started the category 6, that is at least, at most, and exactly. And question number 1 I have already covered, that is at least 2a. Now let's move to the next question. I have given you homework for this question, and I hope you have already designed DFA or NFA for it. So let's discuss this. Okay, so at least 1a and at least 1b. Okay, so this is very simple. Just try to you can say imagine the smallest string in this language. Okay, and then construction will be very easy. So at least 1a and at least 1b. So smallest possible string will be ab and another will be ba. Okay, then we will have a b or a b a, okay, and so on. So there are lots and lots of strings, so no need to worry about all of them. You just need to concentrate on the smallest strings, that is ab as well as ba. Okay, so just try to construct. This is very simple case. So let us take, this is your initial state, that is q naught. Okay, this is your initial state q naught. Okay, and on reading a, we will move to state, say, q1, and on reading b, we will move to state q2. Since we have got at least 1a and at least 1b in this string ab, so this will be our final state q2. And on reaching final state, we do not need to worry about any a's or any number of a's or any number of b's. So we will have self loop of ab. Okay, now on q naught, if we read a b, okay, on q naught, if we read a b, then we will move to state, say, q3, and on reading a, we will immediately jump to q2. Okay, because the string will have at least 1a and at least 1b. Okay, now just tell me one thing, is it a dfa or nfa? This is nfa. Why nfa? Because we have a dead configuration. See here, see carefully, this is a dead here we have dead configuration. Why? Because on q1 we have only b. What about a of q1, and what about b of q3? So this is very simple. You can easily I think you have already guessed, its a will be on q1 only. Okay, so we will have a self loop of a. Why? Because after reading a, we are at q1, and we can read any number of a's. See, after reading a, we are at q1, and on q1 we can read any number of a's. Okay, and as soon as we get a b, the string will have at least 1 and at least 1b. We will move to the final state. Okay, so I think you have guessed it right, that on q1 we will have self loop of a. Similarly, on q3 we will have self loop of b. Okay, these are very simple questions. You can easily figure them out. Okay, let's move to next question. Next question is at most 2 a's. Okay, at most 2 a's. Okay, so again this is very simple. So language will be, see, we are not concerned with b's, we are concerned with a's only. So null will be accepted because it will have at most 2 a's. Single b will be accepted because at most 2 a's. Double b will be accepted at most 2 a's. Dot. Okay, single a is accepted, double a is accepted, double a b is accepted. Dot. Okay, I hope you have guessed it by now, that what will be how your dfa will look like. Okay, so let's design it. So on q0 will be our initial state. Okay, we are not concerned with b, so we will have self loop of b. Okay, because since we are not concerned with b, so on b we will not change the state. Okay, so on q0 we will have self loop of b. Then after reading a, we will move to state, say, q1. Okay, and see here, null is accepted, so initial will be final. Okay, and any number of b's are also accepted. Now that's why we have self loop of b. Now on reading a, we will move to q1. Okay, and q1 will be also final. Why q1 will be final? Because this is because the string will have a string can have at most 2 a's now, so we have only one a till now. Okay, now we are not concerned with b's, so we will have self loop of b. Now after reading a, we will move to state, say, q3. Okay, and q3 will be also final state. Why? Because we have till now at most 2 a's only. Okay, or you can say exactly 2 a's. After reading exactly 2 a's, we are at q3. Now self loop for b, and as soon as we get a, we will move to state Q4, that will be our dead state. Okay, and on dead state we will have a loop of a comma b. Okay, I hope this is very simple case. You have already guessed. I think you have already I have given you homework for this question, so I hope you have already designed this DFA. You just compare your DFA with my DFA. That's it. Okay, let's move to next question. And if you want NFA, then remove this dead state. That's it. Okay. Now let's move to next question. Next question is at most 1A and at most 1B. Okay, this is again very simple. At most 1A and at most 1B. Okay, so let's design it. So null will be accepted now in the language. Smallest possible string will be null because it will have at most 1A, at most 1B. Single A will be accepted, single B will be accepted. Okay, and after that A be accepted, B A accepted. Okay, so let's design it. Okay, so initial is final. Why? Because null is accepted. After reading A, we will move to state say Q1. Okay, we will move to Q1, and this will be also final state because single A is accepted. On reading B, we will move to state say Q2, and Q2 will be also final state. Why? Because single B is also accepted. Then AB is accepted. Okay, so after reading A, if we read B, then we will move to state Q3, and it will be also final state. Why final? Because AB is accepted. Now at most 1A and at most 1B I have said. So on reading A, we will move to say state Q4, that will be also final. Okay, so AB be accepted. Now after AB or after BA, if we get anything, then string must be rejected now, because at most 1A and at most 1B we have already said. So after this, if we get either A or B, here also if we get either A or B, we will move to a dead state, and on that state we will have self loop of A comma B. Okay, now can you guess that can you see this is NFA or DFA? I think you have already guessed that this is NFA. This is not DFA. Why this is NFA? Because on Q1 we have not talked about A, and on Q2 we have not talked about B. Now tell me where after reading A on Q1 where we should go. Okay, so after reading A, I think you have already guessed. After reading A, we will move to dead state. Why? Because we have read 2 A's and we need only we need at most 1 A, but in string we have already got 2 A's, so hence string must be rejected. So we will move to dead state. Okay, and after reading 2A, anything can come. String will be obviously rejected. Similarly, on reading B, okay, on Q2, after reading B, we should again move to dead state only. Okay, on B we will move to dead state only. Okay, or let me take it from here itself. Okay, on reading B we will move to dead state. Okay, so please note it down. We will move to next slide now. Okay, next question is exactly 2A. Exactly 2 is again very simple. Okay, you can directly make it. Okay, or let me make it for you in a very faster manner. So exactly 2A na. So we are not concerned with B's. So on we will have self loop for B on Q0, and null is rejected now. Why null is rejected? Because we need exactly 2 A's. Okay, so null will be rejected. Null does not have exactly 2 A's. Okay, now after reading A, we will move to Q1. After reading another A, we will move to Q2. Okay, and here we will have self loop of B. Why? Because we are not concerned with B's. Again here we will have self loop of B's because we are not concerned with B's. Okay, and since we have read exactly 2 A's, Q2 will be our final state, and after that, even if we read any A, we will move to state Q3. That will be our dead state, and on that state we can have any number of A's and B's. Okay, so I think you have already designed this. So this is very simple scenario. Okay, so please check this. Is it NFA or DFA? We have directly constructed DFA, no? Because on Q0 A and B are completed, Q1 A and B are completed, Q2 A and B are completed, and Q3 also A and B are completed. Okay, so unique move and no dead configuration, hence this is we have constructed directly DFA for it. Okay, let's move to next question. Exactly 1A and exactly 1B. Okay, so again very simple, exactly 1A and exactly 1B. So null should be rejected now, because null does not have exactly 1A and exactly 1B. So smallest string, I think you have already guessed, in the language smallest strings will be AB and BA. So just consider it on them. Okay, and rest will be easily covered. Okay, so on Q0, after reading A, we will move to state say Q1, and on Q1, after reading B, we will move to state say Q2. Q2 will be our final state because it will have exactly one A and exactly one B. And on reading B, we will move to state Q3, and on reading A, we will move to state Q2 itself. Okay, because string BA also have exactly one A and exactly one B. Now see on Q0, A and B are completed. On Q1, B is completed. What about A of Q1? Since we need exactly one A and exactly one B, so as soon as we get another A, we should move to a dead state. Okay, and on dead state or trap state, we will have a self loop of AB. Okay, so we will have self loop of AB. So as soon as we get a, okay, we will move here, or let me use a different color, then it will look nice. On Q1, as soon as we get A, we should move to dead state. Similarly, on Q3, and Q3A is completed. What about B of Q3? As soon as we get a B, we should move to dead state. And on Q2, as soon as we get either A or either B, okay, we should move to either A or B, we should move to dead state only. Okay, because we need exactly one A and exactly one B. Okay, I hope I have made the point clear to all of you. So this is again very, very simple DFA. We have directly constructed DFA for it. Okay, now let's move to next category of questions, that is finite language. Okay, so in finite language, so let us take a language in which we have only two strings, that is 0, 1 and 0, 1, 1. Okay, so let's construct DFA for it. Okay, directly construct DFA for it. So on Q0, whenever we read 0, we will move to Q1. Okay, and after reading 1, we will move to state say Q2. Q2 will be our final state because 0, 1 should be accepted. And on it, as soon as we read 1, we will move to Q3, and Q3 will be also final state. Why? Because 0, 1 and 0, 1, 1, we have to accept these strings. Okay, so 0, 1 is accepted, 0, 1, 1 is also accepted. Now since we are constructing DFA, so see, if the question says construct FA, I have already told you many times, if question says FA means by default FA means NFA. So this is already completed. So we need only 4 states for NFA. But what about my DFA? For DFA, we should have a trap state or dead state also. Okay, so string is 0, 1 or 0, 1, 1. So as soon as we get 1 on Q0, that means what? String is starting with 1, but it should but any string starting with 1 will be rejected now, because string should be start with 0. Okay, so we will move to dead state, and on dead state we will have self loop of 0, 1. Okay, on Q1, as soon as we get 0, we will move to dead state. On Q2, as soon as we get 0, we will move to dead state. On Q3, we get 0 or 1, we should move to dead state. Okay, so this is your final DFA. So this is your final DFA. So DFA will have only one extra state from NFA, and that will be the dead state itself. Okay, let's move to next question. Next question is A power n, B power n is less than or equal to 2. Okay, so this is again very, very simple case. See, we will start with state say Q0, that will be your initial state. N is less than or equal to 2, that means n can be 0. N can be 0 means what? A power 0, B power 0, that will be null. Okay, so null will be accepted, hence initial will be final. Okay, okay, now after reading A, we will move to state say Q1. After reading B, we will move to state say Q2, and Q2 will be our final state. Why? Because when n is 1, then it will be A power 1, B power 1, that is nothing but AB. So AB should be accepted. Okay, next string accepted will be C. In the language, I hope you have already guessed, the language will consist of only 3 strings, that is null, AB, and AA, double B. Okay, because we have kept here n. N means what? If n is 0, then it will be A power 0, B power 0, that is null. When n will be 1, then A power 1, B power 1, that is AB. When n will be 2, then it will be A power 2, B power 2, that is nothing but AA, double B. Okay, now AB is accepted. Now AA, double B should be accepted now. So after reading A, we are at Q1 now. So on Q1, you should read A, and we should move to state Q3. Okay, and on Q3, after reading 1B, where should we move? Okay, after reading 1B, say we should go to state Q4, and on Q4 after reading B we will move to state Q2. Okay, so double A double B is also accepted. So single AB is accepted, double A double B is also accepted. Now after that, okay, on final state, if we get either A or B, we do not need to worry. That will move to a dead state, that is and on that state we will have a self loop of A comma B. Okay, so if the question says NFA, then no need of that state, but if question says DFA, then we have to make that state also. Okay, so when I used to teach in offline classes, then students have a doubt that on Q3 why you are taking B to Q4. Okay, on Q3, see, let me highlight this. On Q3, why we are after reading B, why we are jumping to Q4? We can move to Q1 also. Okay, because on B, after reading B, if we move to Q1, then after reading another B, we will move to Q2 now. So double A double B will be accepted. But if you do like this, then we will have, okay, let me use a different color. Okay, so if you have a loop like this, then this will be obviously a loop, na, A B loop. So string, so lots and lots of other strings will be accepted now, because say for example, say double A B B, this string will be also accepted. See here, double A we will move to Q3, then on single B we will move to Q1, then A on Q3, then B, and then B we will move to Q2. So this string will be accepted, but we need to accept only strings, only three strings, that is null, AB, and double A double B. See, leave everything, just concentrate here. Okay, just concentrate here. Let me use highlighter here. We have a loop of AB, so we can pump AB any number of times. Okay, so this is the basis of pumping lemma also. We will study pumping lemma in pretty much detail in the subsequent lecture. So since this is a loop, na, AB loop, so we can pump AB any number of times. Okay, or so that will create problem for us. Okay, I hope I have made the point clear to all of you. Okay, so please do not think like this, that B should why we are taking an extra state Q4 for B, why we are not jumping to Q1. Okay, I hope I have cleared your doubt. So let's rub it and you can note down. Okay, so please note it down. Now let's move to next question. Okay, so we have completed all the categories, so let me revise you. Okay, let me give you a brief revision. So in this lecture we have completed all the 7 categories of construction of FA. Okay, so finite language was our last category. We have completed this also. Now according to syllabus of chapter 1, we are jumping to the third topic. Okay, third topic, that is your NFA to DFA conversion. If you have not seen my syllabus video, then please I think jump to your first lecture, or I think second lecture. In the second lecture itself, I have discussed the syllabus of your second chapter. Okay, yeah, I have remembered now. In the second lecture of TOC, you will in the starting itself, you will see the syllabus. I have discussed entire syllabus of your chapter 2, that is finite automata and regular languages, and according to that syllabus I am now jumping to the topic 3, that is NFA to DFA conversion. Okay, so let's move on to this algorithm. This is NFA to DFA conversion algorithm. Okay, so name of the algorithm is subset construction algorithm. Okay, so how we are constructing subsets and so on. Let's move to a question, and that question will clear your concepts. Okay, so the question says construct an FA which accepts all those binary strings in which third symbol from right is 0. So let me change this question a little bit. We will construct a DFA. Okay, so how we can construct this DFA? So let me tell you one thing. This is not an easy task. We should first construct NFA, and then we should convert it into DFA. Okay, so first we should construct NFA. Okay, so let me design NFA for you. Okay, so NFA is very simple. Now, third symbol from right is 0. First of all, we should you will get confused that how NFA or DFA can read symbol from right. We cannot read symbol from right now. We cannot read symbol from right. We can read symbol from left to right only. And that means from left we can read. We cannot read symbol from right. So how we will do this? Okay, so this is very simple task. Okay, this is not a difficult task. Let me design it for you. See, let us suppose this is your final state. Okay, on final state. Okay, so after reading the last symbol, we will move to final state. We will assume like this. Okay, so last symbol can be 0 or 1. Okay, it won't create any problem for us. Similarly, second last symbol can be 0 or 1. It won't create any problem for us. But third last symbol should be 0. Third last symbol should be 0. Hai na? This is the case. Na? Third symbol from right is 0. Na? So third last symbol should be 0. And this will be your initial state. On initial state, we can have self loop of 0, 1. So we can read anything, any number of zeros and 1. And as soon as we get the third symbol, then it should be 0. Then as soon as we get the third last symbol, it should be 0. Then second last can be the 0, 1, or last symbol can be the 0. Okay, so I hope I have made the point clear. So this is your actual NFA. Okay, so this NFA, okay, this NFA will accept all those binary strings in which third symbol from right is 0. Okay, please check it out. You will get your answer. Okay, please, this is homework for you. You have to verify that why this NFA is correct and so on. Okay, take some strings, and this should be just like a toy for you. You should be able to play with it. Okay, so let me label the states. Okay, and then I will try to convert it into DFA. Q0, then this should be your Q1, this should be your Q2, and this is your, say, Q3. Okay, so Q0, Q1, Q2, Q3. I hope this is visible to all of you. This is Q1. Okay, or let me label it here. This state is Q1. Okay, and I think rest of the other states are visible to all of you. Okay, so how we will convert it into DFA? Now this is our question. Okay, so let's move to next slide and try to construct it. Okay, so I think I have not left the space, so let me do it here only. Okay, so the first step is your initial state of NFA will be initial state of DFA. So you have to copy paste the initial state itself. Okay, and we will directly make table. Okay, so 0, 1. On Q0, whenever we read 0, we can move to either Q0 or Q1. Okay, we have two choices, na? Q0, Q1. So write it here itself, that is Q0, Q1. Okay, and make a bracket like this. Okay, now on Q0, whenever we read a 1, then we will move to Q0 only. Then, so we will keep here Q0 itself. Now, please do not see the this NFA diagram or table. Just leave anything and just try to concentrate on new states. Okay, so step number 1 is initial state of NFA will be initial state of DFA, and all the moves will be copy pasted. We have moved, we have copy pasted the moves. Now see this. This is Q0, Q1. In NFA, we will say that on Q0, after reading 0, we can move to either Q0 or Q1. Okay, we cannot move to both the states. No, we will move to either Q0 or Q1. That means we have a choice in case of NFA. But now, since we are getting a DFA, so I will say that this is a single state Q0, Q1. Okay, so let me label this thing. If I am constructing a DFA side by side, let me construct it. So on Q0, Q0 was our initial state in NFA and in DFA also. After reading 0, we will move to state Q0, Q1. This will be a new state for the DFA. Okay, please remember this fact. This will, I think many of students get confused by this fact that on Q0, after reading 0, we will move to a new state whose name or whose label is Q0, Q1. Okay, so as the name suggests, this state will have, this Q0, Q1 state will have combined power of both Q0 and Q1. Combined power means wherever Q0 and Q1 will go, that state will go there itself. Okay, so if you are not able to understand, just leave it. Just try to listen me. Okay, then you will get the perfect idea. Okay, so on Q0, after reading 0, we will move to a new state, that is Q0, Q1, and on Q0, after reading 1, we are moving to Q0 only. So how I am doing this? Okay, how I am leaving this from this NFA itself. Okay, now just leave everything and try to concentrate. We get a new state, that is Q0, Q1. Now try for this state. Okay, so we will keep here Q0, Q1, Q0, Q1. Okay, now on Q0, Q1 on reading 0, where we should go? On Q0, Q1 on reading 0. So just merge them. Na? Okay, so first see on Q0, after reading 0, we are moving to Q0, Q1. So keep it here, Q0, Q1. Now see on Q1 also. On Q1 on reading 0, we are moving to Q2. So keep here Q2 also. So this will be your new state. Okay, if you didn't get an idea, so let me give you let's label the let's make an entry for 1, then you will get more clarity. Okay, on Q0 after reading 1, we will move to Q0. So keep it here Q0, keep here Q0. On Q1 after reading 1, we are moving to Q2. So keep here Q2. Okay, just or you can say just union the states. That's it. You just need to union. So let me do it again. On Q0 after reading 0, just leave Q1, consider it on Q0. On Q0 after reading 0, where we should go? On Q0 after reading 0, we should go to Q0, and we can move to Q1 also. So Q0 Q1, write these states. Now on Q1 after reading 0, we are going to Q2. So just write Q2 also. So Q0 Q1 Q2, this will be your new state. So in Dfa, constructed Dfa, this will be our new state Q0 Q1 Q2. I am not constructed it, not constructing it just to save the time. You can construct it yourself. This is your homework for you. Okay, I am making a table. You can make this state transition diagram also. Okay, now forget about everything. Just concentrate on the new state. So Q0 entry is already present. Okay, so leave it. Now this is your new state now. So please now write it and try to make the moves for it also. Q0 Q1 Q2, this is our new state. So just do it just as I have already said, just do it like this only. On Q0 after reading 0, we are going to Q0 Q1, we are going to Q0 Q1. On Q1 after reading 0, we are going to Q2, and on Q2 after reading 0, we are going to Q3. So this will be our new state. Okay, and on Q0 after reading 1, we are moving to Q0. Okay, and after and on Q1 after reading 1, we are moving to Q2. On Q2 after reading 1, we are moving to Q3. Okay, now just concentrate here. So you have completed this state. Okay, let me do it this way, because many states are coming. So let me do it properly. Okay, yeah. So okay, so we have already talked about Q0 Q1 Q2. Now the next new state is Q0 Q2. We have not made entry for Q0 Q2, so let's make entry for Q0 Q2 also. Okay, on Q0 Q2 on 0, see on Q2 on Q0 after reading 0, we can move to Q0 Q1, Q0 Q1, and on Q2 after reading 0, we are going to Q3. So Q0 Q1 Q3. Similarly, on Q0 after reading 1, we are moving to Q0, and on Q2 after reading 1, we are moving to Q3. Okay, now see carefully which is our new state here. Okay, which is not yet covered. This is our new state. Okay, so let's make an entry for it. Okay, and please try to make, I'm speaking again and again, please try to maintain sequence, otherwise you will get confused in exam. See, the initial state is copy pasted, the moves are copy pasted. Now the new state was Q0 Q1, which we have already covered. Next Q0 was already covered. Then Q0 Q1 Q2, Q0 Q1 Q2 is already covered. Then Q0 Q2 is already covered. Now the next state is Q0 Q1 Q2. So let's cover it also. Okay, so let's make an entry for it. Say Q0 Q1 Q2 Q3. Okay, now on whenever we read 0 on Q0, where we will move, we will go to Q0 Q1, Q0 Q1. On Q1 on reading 0, we will move to Q2. On Q3 on reading 0, we are going to nowhere. Okay, let me recheck it. On Q0 after reading 0, we are going to Q0 as well as Q1. Okay, Q0 Q1. On Q1 after reading 0, we are going to Q2. Okay, and on Q2, after reading 0, we are going to Q3 also. Yes, I have skipped one state. Okay, so on Q2, after reading 0, we are going to Q3. Okay, so this, and on Q3, after reading 0, we are going nowhere, so leave it. So Q0, Q1, Q2, Q3. Okay, now on Q0, after reading 1, we are going to where? We are going to Q0 only. Q1, after reading 1, we are going to Q2. Okay, next on Q2, after reading 1, we are going to Q3. Okay, yes, on Q3, after reading 1, we are going nowhere, so leave it. Okay, now we have covered Q0, Q1, Q2, Q3. Next new state is Q0, Q2, Q3. Okay, let me tell you one thing. This is I think you are feeling that this is very long example and so on, but this is the best example to study this algorithm, that is subset construction algorithm. If you got this example, then you can solve any question on NFA to DFA conversion. Okay, so please keep this thing in mind. Okay, so no doubt this example is pretty long, but it will cover lots and lots of concepts. Okay, so the next new state is Q0, Q2, Q3. So let's cover it. Please maintain the sequence. I am speaking again and again. Q0, Q2, Q3. Okay, now on Q0, after reading 0, we are going to Q0, Q1. On Q2, after reading 0, we are going to Q3. And Q3, after reading 0, we are going nowhere. Okay, on Q0, after reading 1, we are going to Q0 only. And after reading on Q2, after reading 1, we are going to Q3. And on Q3, after reading 1, we are going nowhere. Okay, this is your so we have covered Q0, Q2, Q3. Now the next new state is Q0, Q1, Q3. See in the list, have you covered Q0, Q1, Q3? No, we have not covered it. So let's cover it. Q0, Q1, Q3. Okay, so on Q0, after reading 0, we are going to Q0, Q1. On Q1, after reading 0, we are going to Q2. And on Q3, after reading 0, we are going nowhere. Okay, now on Q0, after reading 1, we are going to Q0. On Q1, after reading 1, we are going to Q2. And on Q3, after reading 1, we are going nowhere. Okay, so let's see. Now we have covered Q0, Q1, Q3. Next is Q0, Q3. Have we covered Q0, Q3 already? No, we have not covered it. So let's cover it. Q0, Q3. Okay, so on Q0, after reading 0, we are going to on Q0, after reading 0, we are going to Q1. And on after reading Q0, after reading 0, we are going to Q0, Q1. Sorry for that. Q0, Q1. Okay, and on Q3, after reading 0, we are going nowhere. So Q0, Q1. Q0 on 1, we are going to Q2. Okay, and side by side, we should see on Q0, after reading 1, we are going to Q0 only. No? Sorry for that. On Q0, after reading 1, we are going to Q0 only. And on Q0, after on Q3, after reading 1, we are going nowhere. So it will remain Q0 only. Okay, so we have covered Q0, Q3 also. Now the next new state is Q0, Q1, Q2, Q3, which we have already covered. Q0, Q2, Q3, we have already covered. Q0, Q1, Q3, Q0, Q1, Q3 already covered. Q0, Q3, Q0, Q3 is already covered. Q0, Q1, Q2, Q0, Q1, Q2. Yes, we have already covered Q0, Q1, Q2. The next is Q0, Q2. Next is Q0, Q2. Q0, Q2 we have already covered. Q0, Q1 already covered. Q0 already covered. Okay, so now since we do not since no state is left uncovered, so this is your final converted DFA. Okay, now again I am saying if you want, then this is homework for you. You can convert this state transition diagram, your table method, into state transition diagram. Okay, I have just initiated the work for you to give you an idea that Q0, Q1 is our new state. Okay, so new state labeled is Q0, Q1. This is a single state. Okay, in NFA, these were two states, Q0 and Q1. These two were separate states. But whenever we are constructing DFA from the given NFA, then this will be a combined state. Okay, so you can say this is a single state Q0, Q1, and this will have a combined power of both Q0 as well as Q1. So wherever Q0 and wherever Q1 were going on reading 0 and 1, that state will go there itself. Okay, so I hope I have made the point clear to all of you. So this is, you can say, see, count the number of states: 1, 2, 3, 4, 5, 6, 7, and 8. Total 8 states are present in this converted DFA. Okay, in NFA we were having 4 states, and in converted DFA we are having total 8 states. Okay, okay, so okay, what about my final states? So whichever state is having Q3, that will be our final state. Okay, so Q3 is present in, see, Q3 is present in state this. Okay, Q3 here also, Q3 here also, and Q3 here also. So total 4 states will be final in this converted DFA. Okay, and let me tell you one more important fact about this scenario, that whenever we are converting NFA to DFA, so if NFA is having n states, this is very, very important point, please listen it carefully. If NFA is having n states, if NFA is having n states, then converted DFA can have at most 2 power n states, at most 2 power n states. Okay, please write it carefully. If given NFA is having n states, then converted DFA can have at most 2 power n states. From where we are getting this 2 power n? Because subset construction, na? So for a given set, total number of subsets possible are 2 power n. If the given set has n elements, then total number of subsets possible will be 2 power n. I hope you already know this fact. This is power set. Power set of a given set has 2 power n elements. If given set has n elements, then power set will have 2 power n elements. From that case, we have derived this thing. Okay, so if given NFA is having n states, then converted DFA will have at most 2 power n states. Okay, so please note it down properly. Okay, so just for the sake of completion, let me give you an idea of another question. Okay, now see this: construct a DFA which accepts all those strings, over A and B, which ends with double A or double B. Okay, so let me make a NFA and then I will convert it into DFA. Okay, so given NFA will be what? Strings end with double A or double B. Okay, so this will be our final state. Okay, ending with double A or double B. Now A. Now this will be our initial state on reading double A, and ending with double A, we are at final state. Ending with double B also, so B and B, ending with double B also. Okay, and on initial, since this is ending now, so on initial state we can have a loop of A comma B. Okay, so any number of A's and B's can come on initial state, and whenever string is ending, then last 2 characters must be double A or last 2 characters must be B. Okay, so I hope I have made the point clear. This is the your given NFA which ends with double A or double B. Okay, so let me label the states. So this state is say Q0, this state is say Q1, this state is say Q2, and this state is say Q3. I hope this is visible to all of you. Okay, so these are the total 4 states in this NFA. Now we want to construct a DFA. See, this is very, very simple task. This is homework for you. You can directly convert it into an NFA. So sorry, into a converted into DFA. But I will make use of this algorithm. Okay, to make converted DFA. Okay, and let me tell you. I think I have already told you about this thing, but let me give you another. You can say, let me repeat this fact, that if you try to construct direct DFA. DFA which accept all those binary strings, and your third symbol from right is 0. This is almost impossible. Rather, I should not say impossible. It will be very, very difficult for you. NFA construction is very easy. And hence we converted it into a DFA. Okay, so this is the basic, you can say, application of NFA to DFA conversion algorithm. That if you are able to design NFA, but you are not able to construct a DFA for it, then use this algorithm. Okay, so on the similar basis, on similar background, I'm saying like this, that you have constructed NFA on a very fast pace, Okay, and now you want to convert it into DFA. So how we can convert it into DFA? Using that algorithm only. So let's build the idea very on a very fast pace. Okay, so step number one was what? Initial state of your converted DFA will be same as your NFA itself. Okay, so A and B. Okay, so let me put B here. Okay. Okay, now this is good. Okay, on Q naught, since Q naught was our initial set, on Q naught, whenever A is read, then we can go to Q naught, or we can go to Q1 also. So Q naught, Q1. Okay, so this will be our new state. On Q naught, after reading B, we will move to Q naught also and Q2 also. Q naught, Q2. Okay, now the new state is Q naught, Q1. So make it so cover it Q naught, Q1. On Q naught, after reading A, we are going to Q naught, Q1, and on Q1, after reading A, we are going to Q3. Okay, on Q naught, after reading B, we are going to Q naught, Q2. On Q1, after reading B, we are going nowhere. Okay, so state will be Q naught, Q2 itself. Now new state is Q naught, Q2. Okay, so we have covered Q naught, Q1, and next is Q naught, Q2. So let's cover it. Q naught, Q2. On Q naught, after reading A, we will go to Q naught, Q1. Or Q2, after reading A, we are going nowhere. So leave it. On Q naught, after reading B, we are going to Q naught, Q2. And on Q2, after reading B, we are going to Q3. Okay, so next is Q naught, Q1, Q3. Q naught, Q1, Q3. Q naught, after reading A, we are going to Q naught, Q1. On Q1, after reading A, we are going to Q3. And on Q3, after reading A, we are going nowhere. Q naught, after reading B, we are going to Q naught, Q2. And on Q1, after reading B, we are going nowhere. Q3, after reading B, we are going nowhere. Okay. Now see, any new state is left. Q naught, Q2 is covered. Q naught, Q1, Q3 is already covered. Q naught, Q2 is covered. Okay, now Q1, Q naught, Q1. Q naught, Q1 is already covered. Q naught, Q2, Q3. This is not covered. So let's cover it. Q naught, Q2, Q3. Q naught, Q2, Q3. Q naught, after reading A, we are going to Q naught, Q1. Q2, after reading A, we are going nowhere. And Q3, after reading A, we are going nowhere. So Q naught, Q1. Now on B, Q naught on B, we are going to Q naught, Q2. Q2 on B, we are going to Q3. Q3 on B, we are going nowhere. Okay. So let's see this. Q naught, Q1, Q naught, Q2, Q3 is covered. Q naught, Q1, Q3 is already covered. Q naught, Q2 is already covered. Q naught, Q1 is already covered. And Q naught, Q2, Q3 already covered. So total 5 states in this converted DFA. So given NFA is 4 states, converted DFA is having 5 states. Okay, so from the fact which I have told you in the previous slide, that DFA can have at most 2 power n state, we can see or we can verify this fact here also. See, given NFA was having 4 states, so converted DFA can have at most 2 power 4, that is 16 states. So we are having 5 states. So I think it is okay. So 5 is less than or equal to 16. So this is also okay. At most 16. So we can have at most 16 states, but here we are having 5 states. This is okay and perfectly fine. So we have verified the previous fact also. Okay, now let's move to next type of you can say next topic. Okay, so please note it down. Okay, one more fact, one more question is coming in my mind. Okay, so I think it may confuse you. See, on initial state, if we are having NFA like this, on initial state, we are reading A and we are going to Q1, and Q1 is your initial, Q1 is your final. That means this is NFA which accept all those strings over A and B which starts with A, na? Which starts with A. Okay, so this is your NFA. Now we want to convert it into DFA with your algorithm. Okay, without algorithm obviously you can convert, but how will you convert using subset construction algorithm? Okay, so as I have said you already that initial state will be copy pasted, na? Most of initial state will be copy pasted. So here, okay, so here we are reading A as well as B. Now on Q note after reading A we are going to Q1. On Q note after reading B, where we are going? We have a dead configuration here. Now since we are having a dead configuration here, so what should we do? So in that case you have to apply dead state here. Okay, I think you have already guessed, and most of the students have already guessed right that we should have a dead state. Okay, so on Q note after reading B, we will go to a dead state, and on dead state, and on dead state directly may make moves like D and D. On A also we will move to dead state only, and on B also we will move to dead state only. Okay, now see the new state. That is, new state is Q1. Okay, and on Q1 after reading A we are going to Q1. After reading B we are going to Q1 itself. So this is your converted DFA with your algorithm. Okay, and you can check it out also. Q0 is your initial state. On reading A we are going to Q1. On reading B we are going to dead state. Okay, and on dead state we are having loop of AB, and Q1 will be our final state now. Q1 will be our final state. Okay, and we have a loop of A comma B. On A and B we are going to Q1 only. Okay, so this is your converted DFA with the help of algorithm. So the only thing which may confuse is that on initial state if we have a dead configuration, then what should we do? On initial state if we have a dead configuration, then we will move to dead state only. Okay, so I hope I have made the point clear. Okay, and I think I have skipped the point here that what will be the final state. So whichever state which is having Q3, that will be our final state. So Q3 is present in this state also and this state also. Okay, so these two state will be final, and Q0 will be our initial state. Okay, so I hope I have made the point clear. So I think now this algorithm will be crystal clear to all of you. Now let's move to next algorithm, that is minimization of states of DFA. This is again very simple algorithm. So just concentrate on the facts and figures. Okay, so see here. See, the main aim of DFA is you can say or DFA or NFA is acceptance or rejection of string. Na? So we will have two set of states. One will consist of non-final, another will consist of final states. Okay, so first of all you should know that why we are using minimization of states of DFA. Okay, why we are using this algorithm. See, for any regular language, I will talk about it later, but let me give you a small idea. For any regular language we can construct infinite NFAs as well as DFAs. Till now I know you do not know about what is regular language, what is CFL and so on, but I will talk about it later. So just concentrate on one thing. Leave regular language also. Just concentrate on one thing, that for a language we can make, okay, we can make infinite NFAs and DFAs. Okay, so which DFA will be the best according to you? That DFA will be best which is having least number of states, or minimal DFA. Okay, we call it as a minimal DFA. So our concentration is on designing minimal DFAs only. Okay, we do not want to construct DFA which has more and more number of states. So if we have a DFA which has more number of states, we want to convert it into a minimized DFA, or which is having less number of states. Okay, so for that we are using minimization of states of DFA. Okay, so we have a DFA and we want to minimize it. Minimize it means what? We the same, or you can say the equivalent DFA, okay, which will accept the same language as the given DFA, and but the you can say the converted DFA will have lesser number of states as the given DFA. Okay, so we have a DFA. See for example here we have a DFA with 8 number of states. Okay, and after minimizing, say we get 5 or 6 states. This is the better choice now, and the both DFAs will be equivalent only. Okay, so we have see, this DFA will be accepting some language. Okay, whatever language is accepted, just leave it. It is accepting some language. So let us label this as DFA number 1. This is your DFA number 1. Now after minimization we get a DFA, say DFA number 2. Okay, now I am saying that these two will be equivalent. Equivalent in the sense that language accepted by DFA 1 will be same as language accepted by DFA 2, but DFA 2 will have lesser number of states as compared to DFA 1. That's it. Okay, so that's why we are using minimization of states of Dfa. Okay, so we want to construct a Dfa which is having minimum number of states. Okay, so if we have constructed a Dfa and it may or may not be minimum, so we can minimize it with the help of this algorithm. Okay, so let's study this algorithm, and let me tell you one thing. If your Dfa, if you have constructed a Dfa in a pretty bad manner, or you can say minimum Dfa for a language maybe of 3 or 4 states, but you have constructed a Dfa say of 50-60 states. Okay, now after minimizing after this algorithm, you may get Dfa of 10 to 11 states. Okay, so you may not reach the best Dfa with the help of this algorithm. I want to clear this thing. Okay, so if your given Dfa is not perfect, okay, or if you have made a Dfa which is, you can say, a very bad, you can say it's having a very large number of states, so this algorithm will not construct Dfa for the language which is minimum, or you can say minimal Dfa. Okay, so I will talk about this thing in pretty much detail after a few lectures also. Okay, so please, if you are not able to get it properly now, then it's not a problem. I will completely repeat all these steps later on. Okay, after few lectures I will repeat all these things, because we will have a concept of minimal Dfa, we will have concept of regular languages, and so on. And after studying regular languages, I will repeat all these things. Okay, don't worry about it. So I just want to say one thing. Okay, if you want to note it down, then you can note it down just one thing, that this algo, okay, this algo, we are going to study some algorithm now which will minimize the state of Dfa. This algo may or may not give. Okay, this algo may or may not give minimal Dfa for the language. Minimal Dfa for L, for language L. Okay, so again I am repeating, if you have constructed Dfa of 40-50 states, and for a language L, let us assume for language L, minimum Dfa or minimal Dfa has 5 states, Now you have constructed a Dfa, of 50 states, Now you apply this algorithm and you get Dfa of 10 states. Now obviously this is not minimal Dfa, okay, because minimal Dfa I have already told that it will be of 5 states. So we may or may not reach 5-state Dfa. Okay, or if you have by method 1 you have constructed Dfa with 50 states, by another method you have constructed a Dfa of say 30 states. Okay, now you have given this Dfa of 30 state to algorithm, and this algorithm is giving us Dfa of 5 states, so that will be obviously the minimal Dfa. Okay, so so the main aim of saying all these facts is that this algorithm, this minimization of states of Dfa algorithm, may or may not give the minimal Dfa for the given language. Okay, so it may or may not give the minimal Dfa, but whatever Dfa which we will get as an output from this algorithm, that Dfa, or you can say output Dfa and the input Dfa, let me use a different color, the input Dfa and the output Dfa, both will be equivalent. That means they both will accept the same language. Similarly, this was the input Dfa to algorithm of 30 states, and this is the output Dfa for of 5 states. So this is the input Dfa of 30 states, and this is the output Dfa of 5 states, and obviously these two will be equivalent. This is the, you can say, main aim of algorithm. So main aim of algorithm is not the fact that the main aim is not to give a minimized Dfa or minimal Dfa for the language. The main aim here is, if you have a Dfa, then this algorithm will minimize the number of states in that Dfa in such a way that the input Dfa and the output Dfa will accept the same language. Okay, or in simple wording I can say that I will be able to merge a few states with the help of this algorithm. That's it. Okay, so I hope I have made the point clear. If you are not able to follow me, then please rewind the video and watch it again. Okay, so so now I am going to tell you something about this algorithm. Okay, so see how this algorithm works. Okay, so step number one is very simple. Since the aim of DFA is you can say acceptance or rejection of string, so we will have two set of states. Okay, that is final and non-final. So non-final are Q0, Q1, Q3, Q5, Q6, Q7, and final are Q2, Q4. Okay, now just check the behavior of each and every state. So initially, let me tell you one thing also. Initially, we assume that the given DFA was having 8 states. Now initially we are assuming that we have only 2 states, that is final as well as non-final. This is one state. Consider it as a one state, that is final state, and consider this whole as a one state, that is the non-final state. So this state is having actually 1, 2, 3, 4, 5, 6, 6 states in it. Okay, so consider this as a single state, okay, which internally contains a 6th state. Okay, now just tell me, just tell now I'm going to tell you about this algorithm. Okay, so just see it carefully. On Q0, check the behavior of each and every state. That's it. On Q0, after reading 0, we are at Q0 now. So please do not make arrow on Q0, just make arrow on this entire state. That means on Q0, after reading 0, we are at this state only. On 1, we are at Q1. So do not make arrow on Q1, just say that we are at this entire state only. Now, so behavior of Q0 is what? 0 and 1 both will lead to this state only. Now on Q1, on reading 0, we are going to Q2. On reading 0, we are going to Q2. That means on this state. And 1, we are going to Q3. So 1 is here only. So let me tell you one thing. In the next step, Q0 will move separate with Q1. Okay, so or you can say, see, these are the members of a house. We have a house, and these all are members of this house. So if the members have same behavior, they will keep on living in the same house. If the member have different behavior, then they will be kicked out from the house. Okay, so see, if you yeah, if you have if you are not having similar behavior as your parents, then you will be obviously kicked out from your family, and they will say that you are not of our kind and so on. If you are doing some bad things and so on, so they obviously your parents will kick you out from your house. Okay, so this is the same scenario here. We have a house, and in house 7 members are living. Q0 is saying I will remain in this house only. On 0, on 1, I will remain in this house. Q1 is saying that on 0, I will move out of house, and on 1, I will remain in the house. So their behavior is different. So in the next step itself, I will say that Q0 will behave separately. Q0 and Q1 will have separate behavior, so they will have a separate house. So Q0 and Q1 are separated. Now on Q3, Q3, see, on 0, it is going to Q6. Q6 means what? In the same house itself. 0 on same house. And on 1, it is going to Q7, that is on same house only. So 0 and 1 in the same house itself. So it will go with Q0 only. So Q3 will go to Q0. Q3 and Q0 will live in same house. Okay. Q5, what about my Q5? See the behavior Q5. On 0, it is going to Q0, and on 1, it is going to Q1. That means again in the same house itself. So Q5 will go with Q0. Okay, now on Q6, on 0, it is going to Q6. Q6 on 0 is going to Q6. That means in the same house. 1, it is going to Q7. That means in the same house. So Q6 will also go with Q0. Q6 will also go with Q0. Q6 will also go with Q0. Okay, so Q1 is separated. Nobody is going to nobody is willing to come with Q1. Okay, it's fine. So on C Q7 on 0, it is going to Q1. Q7 on 0, it is going to Q1. Q1 means what? In the same house only. And on 1, it is going to Q0. That means same house only. So Q7 is also going with Q0. Now Q1 is separated. Now see the behavior of Q2 and Q4. Q2 on 0, it is going to Q0. That means in this house. On 1, Q2 on 1, it is going to Q4. Q4 means what? Here. Okay, so 0 is outside, 1 is inside. See Q4, on Q4 on 0, it is going to Q2. 0 is inside, and Q1, Q4 on 1, it is going to Q3 now. So 1 is outside. See, the behavior is different now. Q2 1 is inside, 0 is outside. Q4 0 is inside, 1 is outside. Their behavior is different, so they will get separated. Q2 Q4, husband wife, they are not, you can say their behavior is not matching, so they are so they will take divorce and so on. Okay, so Q2 and Q4, sorry, it was bad example. Okay, so let's concentrate here. So till now, Q0, Q3, Q5, Q6, Q7, they all are in the same, they all are behaving similarly, so they are in the same state. Q1 is separate, Q2 is separate, Q4 is separate. So now try to break it. Okay, step by step. Please do it step by step, otherwise you will get confused. Okay, so in the first step itself, I have separated the big state, that is the state with, you can say, 6 members, into 2 states, one with 5 members, another with 1 member, and the state with 2 members is separated into 1 member each. Okay, so leave all these states because they are already separated, we cannot separate it out more. Okay, now on Q0, after reading 0, now same step again and again, do same step again and again. Okay, till you think that we are not going to separate them out further, so then we will stop. Okay, so on Q0, after reading 0, we are going to Q0, that means again inside. Do not say, please, I am repeating again, do not say on Q0 reading 0 on Q0. No, I am moving on this entire state itself, that means in the house itself. 1, I am going outside, so Q0 is going outside on 1. Okay, now on Q3, 0 means what? 0 means inside, that means Q6, and 1 means Q7, that means again inside. Okay, so now they will be separated. Okay, now they will be separated, so just separate them out. Q0 behavior is what? 0 inside, 1 outside. But Q3 behavior is what? Similar, that means 0 and 1 are inside only, so Q3 will be here. Okay, now Q5, see the behavior of Q5. On 0, it is going to Q0, that means Q5 on 0, it is inside, and on 1, it is going to Q1, that means on 1, it is going outside. On 1, it is going outside, so 0 inside, 1 outside. It is just like Q0 behavior now, so it will go with Q0. Okay, now Q6 on 0, it is going to Q6, that means inside. 0 is inside, and 1 Q7, that means again inside. So both are inside. Both inside means what? Q3 type. So it will go with Q3. What about Q7? Q7 on 0, it is going outside. Please see it carefully. Q7 on 0, it is going outside, and on 1, it is inside. Please see it carefully. Q7, 0 is outside, 1 is inside. Q0, please do not say that Q7 and Q0 have same behavior. Q0, 0 inside, 1 outside. Q7, 1 inside, 0 outside. So hence Q7 will move separately. Okay, Q7 will move separately. And we have Q1, we have Q2, we have Q4. Okay, now just try to separate them out. Are you able to separate them out? Please see it properly. On Q0, after reading 0, we are going to Q0. Q0 after reading 0, we are going to Q0. That means in this house itself, on 1, it is going to Q1. On 1, it is going to Q1. Okay, Q5 on 0, it is going to Q0. That means in this house itself, and Q5 on 1, it is going to Q1. It is going to Q1. Now these two cannot be separated. Okay, they have exactly similar behavior. Now Q3, check for Q3. Q3 on 0, it is going to Q6. Q3 on 0, it is going to Q6. That means 0 is inside, and Q3 1 is going to Q7. Q3 1 is going to Q7. Okay, now see the Q6 on 0, it is going to Q6. That means 0 is inside, 1, Q6 on 1, it is going to Q7. It is going to Q7. That means exactly same behavior. Okay, so these two cannot be separated out. Now Q7, Q1, Q2, Q4, you can leave them because they are already single states. Okay, so finally I can say that Q0 and Q5 will be merged, Q3 and Q6 will be merged. So total states in the given DFA were 8. Now in the converted DFA we will have only 6 states because we have merged Q0, Q5 and Q3, Q6. Okay, and the language accepted by this DFA and this DFA will be exactly same. Okay, so if you want your converted DFA, then I can easily make it. Do you want me to make it, or can I give you as a homework? Okay, so so let me do it here only. Okay, that will be beneficial for you and it will save our time also. Okay, so let me do it here only. Okay, so Q0, Q5 have same behavior now. So just delete one state, either Q0 or Q5, whatever state you want to delete. Let's delete Q5. So we are deleting Q5. Okay, so please see the labels. Wherever we have Q5, just make it Q0. We are going to Q5 from any state? No, we are not going to Q5 from any state. So we can leave this thing. Otherwise, if we have Q5 in any cell, then we will make it Q0, because now Q0, Q5 has only because we have merged these states. Okay, similarly Q3, Q6. So you whatever state you want to delete, you can delete Q3 or Q6. Say let's delete Q6. Q6 we have deleted. Now, wherever we have Q6 in the cell, just make it Q3. So here we have Q6 now, make it Q3. Okay, make it Q3. Here we have Q6, so make it Q3. Okay, make it Q3. Anywhere we have Q6? No, we don't have a Q6 anywhere else. So that's it. So this is your converted DFA. Now Q0, Q1, Q2, Q3, Q4, and Q7. We have only 1, 2, 3, 4, 5, and 6. We have only 6 states in the converted DFA. Okay, I hope I have made the point clear to all of you. Okay, so if you have any kind of confusion, or if you are facing any kind of difficulty, then please rewind the video and watch it again. I hope I have made the point crystal clear to all of you. Okay, so just solve one more question and our video will be over for today. Okay, so let's do it. Okay, so step number 1 will be we will make final and non-final states now. Q0, Q1, Q2, Q3. All these are final and one non-final, that is Q4. Okay, so forget about Q4 because there is only this is only single state. We cannot divide it further. In this house we have 4 members, so we can think of dividing them. Okay, so on Q0, after reading 0, we are going to Q2. Okay, that means in the same house. 0, same house. 1, 1 also same house. Okay, Q1, 0, same house. 0 is same house. 1, 1 is also same house. Q2, 0, 0 is same house, and 1 also same house. Q3, 0 outside, 1 same house. Okay, so now you can easily guess Q0, Q1, Q3. Okay, these will be these 3 are having similar behavior, but Q3 was having different behavior, so I have separated it out. Okay, now check for Q0. Q0, 0. We are going to Q0, Q1, Q2. Now, sorry for that. I have made a small mistake here. Q0, Q1, Q2. Q0, Q1, Q2 are having similar behavior. Q3 was having different behavior. So I have separated out Q3, Q4, and Q0, Q1, Q2. Okay, now on Q0, after reading 0, we are going to Q2. Now, Q2 is in same house. That means just say we are in the house itself. 1, we are in the house itself. Q1 on 0, we are going to Q3. On Q1 on 1, Q1 on 0, we are going to Q3, and Q1 on 1, we are in the house itself. Okay, Q2 on 0, we are in the house itself, and on 1 again we are in the house itself. So Q1 is having separate behavior from Q0, Q2, and Q0, Q2 are having similar behavior now. So Q0, Q2 same behavior. Q1 is having separate behavior, so just separate it out. Okay, now do not consider it on all these three states because they are already single person in the house. They are 2% in the house, so just try to consider it here. Q0 on 0, we are in the same house. On 1, we are going outside. Q2 on 0, we are in the same house, and on 1 we are going outside. That means in Q1 only. Okay, so see here carefully, they both are having similar behavior, so we cannot separate them out again. Okay, and please if on Q2 after reading 1 we may go to Q3 also. If we are going to Q3, then obviously they are having separate behavior. Now see, Q1 on Q0 1 is going to Q1, and in Q2 1 is going to Q3, so they obviously they have separate behavior. So we will separate Q2 and Q3, but since they are having exactly same behavior, Q0 inside, 0 is inside, 1 is on Q1. Q2, 0 is inside, 1 is Q1. Okay, so they are having exactly same behavior. So I can say that we cannot separate them out. Okay, hence converted DFA will have total 4 states. So Q0, Q1 are Q0, Q2 are merged. So it's all up to you. Either you take Q0 or either you take Q2. So I am deleting Q2. We are keeping Q0. Why we are keeping Q0? Because Q0 is our initial state. We cannot delete it. So just delete Q2. Or if you delete Q0 now, then make Q2 as initial. No problem at all. This is not a problem for us. If you want to delete Q0, just delete Q0. Make Q2 as your initial state. Okay. So I'm deleting Q2. So wherever we are having Q2, just make it Q0. So here we are having Q2, just make it Q0. Anywhere else we are having Q2? No. Okay, that's it. So this is your converted DFA, which is having 4 states: Q0, Q1, Q3, Q4. Okay, I hope I have made the point crystal clear to all of you. Okay, so just remember one thing: whenever we are moving inside now, then do not consider any state inside. Just say that we are in the house itself. But whenever we are going outside the house, then consider the state also, that on which state we are going. Do not say that inside outside like this. Okay, on outside you have to say properly that on which state we are going. But on inside, we are not at all concerned on which state we are exactly going. Just say inside only, because we are in the set itself. Okay, so I hope I have made the point clear. If you are having still any kind of doubt, just rewind the video and watch it again. Okay, so just last time I'm saying on Q0 0 in house itself, but on 1 we are going outside. On outside, on which state we are going? We are going to Q1. And on Q2, after reading 1, we are going outside. But on which state we are going? Q1. Now on Q0, after reading 0, we are inside. On which state we are inside? Please do not say like this. Just say on Q0 after reading 0, we are inside the house. That's it. We are not concerned about either we are going to Q0 or we are going to Q2, because they are a single state only. We are in the house itself. Okay, like I'm remembering the dialogue in Hindi. If you know Hindi, then the dialogue is घर की बात घर में रहनी चाहिए. तो बस वही बात है यहाँ पे. Okay, so just remember this thing, that we want to remain in this house only. That's it. Okay, that's it. So, this is all about today's lecture. So in the next lecture, we will move to next topic according to syllabus of your chapter 1, that is finite automata and regular languages. Okay, thank you so much. Bye bye.